Okay, this is exam 2 for fall 2016, Physics 201. Consider these two vectors. What is the vector A minus B? Okay, so first we draw A, and then we draw minus B, which is the opposite of what we have here. And then the resultant will look like this, so that answer is A. Which of these are scalar quantities? Well, let's see, speed is a scalar quantity, and so is mass, so that's 1 and 3. A certain vector has a net y component, which is larger than its x components. Both are positive and non-zero. Which of these is a possible angle? So since both are positive, that means I'm in quadrant 1, and it says that the y component is larger. So my x component, say, was here. That would mean my y component would be here, so it's going to look something like this. Now, if the x and y components were equal, it would fall right there at 45 degrees. So it can't be A. It has to be bigger than 45, but less than 90. So D is the right answer. If vector A is 12 meters, B is 25 meters, which of these is a possible sum? Well, the maximum would be 25 and 12 lined up like that. That would give me a maximum equal to 37 in magnitude, and the minimum would be 25 and 12 like this, which would give me a resultant of 25 minus 12, which is 13. So it has to be somewhere between 13 and 37, so D is the right answer. Two shells are fired simultaneously from the same battleship at two targets. The shells follow the trajectory shown here. Which target will be hit first? Well, it's going to be target 1. Even though it's farther away, the y displacement is less, and the y displacement gives the time in flight. Which of these true when the height of a projectile is at its maximum? At the maximum, Vy is equal to 0. Remember, Vy starts out big, it gets smaller, and at the top it goes to 0. Vx, on the other hand, remains constant throughout. Which of these represents the y component of the velocity? Well, let's go back here. It starts out initially big, then gets smaller, and then goes to 0, and then it gets bigger in the negative direction. So it starts out big and positive, and goes out big and negative. That's going to be A. Consider the projectiles that follow the paths. Is it possible that all three projectiles have the same initial speed? Yes, all three could have the same initial speed. It's just they would have different angles. So for example, this one might have an angle of 60 degrees, this one might have an angle of 45 degrees, and this one might have an angle of 30 degrees, something along those lines. So yes, all three could have the same speed. So for two-dimensional motion that begins and ends at the same height, all the following apply except, let's see, the acceleration in both the x and y directions does not change. Okay, that is true. Let's look at the others though. The minimum speed of the projectile is just after launch. That's not true. It's actually at the top of the projectile trajectory. The x velocity of the projectile is unchanging. All right, that's true as well. The time for the projectile to ascend is exactly the same as the time to descend. That's true as well. So I'm looking for the things that do not apply, so B is the right answer for 9. An object has many forces acting upon it, but the net force is 0. The object will, well, if the net force is 0, that means the acceleration is 0. That means the velocity will not change. So it will continue at a constant velocity forever. All these others, B, C, and D, require some acceleration. A truck runs into a small car, which exerts a larger force. Well, because of Newton's third law, they both exert the same force. Two objects, A and B, experience the same net force. Object A has twice the mass of object B. So the mass of A is equal to twice the mass of B. It has the bigger mass. Since I know that F equals ma, they experience the same force. If I have twice the mass, that means object A will have half the acceleration. So D is the right answer. Which of these make up the basic SI units of the Newton? Well, F equals ma, so that's kilogram meter per second squared. A. Which of these is another name for Newton's first law? That would be the law of inertia. This would be the second. This would be the third law. The force of a friction due to friction opposes the direction of motion. Okay, let's look at the free response here. Consider these two vectors. I'm going to go ahead and do B, where I sketch the vectors. Vector A is 30 meters along the negative y-axis. Vector B is, oh, excuse me, along the 30 meters along the negative y-axis, so it's like that. And then vector B is 20 meters per second, a lot 30 degrees above the negative x-axis. So I'm going to draw it like this, and it's a little bit shorter. It's going to look something like that. Then the resultant will start here and go there. So this is my resultant, a sketch that looks something like that. I'm looking for the appropriate perspective for the angles, that it's in the right quadrant. It should be in quadrant 3, and that you get these relative sizes at least somewhat correct, that the first one is bigger than the second vector. All right, so I'll be looking at an angle that's, some angle below the negative x-axis and some magnitude that looks like it's between 20 and 30. Now, let's find the sum of these two vectors. So my first step will be to find AX and AY. This one has an AX equal to 0 because it's on the negative y-axis, and AY equal to negative 30. And then I can find BX and BY. BX is going to be 20 cosine 30. It's actually going to be negative 20 cosine 30 and negative 20 sine of 30. So this is negative 17 and this is negative 10 meters per second. Notice that the negatives are here because my vector is 30 degrees above, I'm sorry, the y should be positive. So it's above the y-axis, above the negative x-axis. So that vector is going to be here. It will have a negative x component and a positive y component. Now, to find if r is equal to a plus b, I think that's what I was finding. Yeah, if r is equal to a plus b, then I need to find rx and ry. Rx will equal to ax plus bx. That will be 0 minus 17. And ry will be ay plus by. That will equal negative 30 plus 10, which is 20. So those are my x and y components. Notice the x component is negative, the y component is positive. Hold on, let me take just a break. I'm sorry, I misspoke here. The y component is negative, as it should be. Since I'm in the third quadrant, both the x and the y component should be negative, as they are. Now, I want to find the magnitude of r. It's going to be the square root of 17 squared plus 20 squared. I leave those negatives off because they go away when I square them. And that is 26 meters per second. And then to find the angle, I say the inverse tan of ry over rx, that's 20 over 17. I'm leaving the negatives off, and I'll just find that angle from the negative x-axis. And that is 50 degrees. So it's 50 degrees below the negative x-axis. Or if you wanted to give it from the positive x-axis, you would say 230 degrees, that's 180 plus 50 from plus x. I would take either. All right, let's look at this next one. A cannon fires a ball with initial velocity at 100 meters per second from 30 degrees from the horizontal, lands some distance away. How long is it in the air? What is the horizontal range and the maximum vertical range? Okay, so I have projectile. It follows this path. I want to first, let's go ahead and calculate what V naught x and V naught y are. V naught x is going to be 100 cosine 30. V naught y is 100 sine of 30. It's going to be 87 meters per second and 50 meters per second. V naught x and V naught y. I want to know how long it's in the air. I can do it a couple of ways. I'll consider this, that Vy at the top here is equal to 0. If I do that, I say Vy equals V naught y plus Ay t, and I'll call this t top. 0 equals 50 plus negative 10 times t top. Solve that for t top equals to 5 seconds. So t total equals twice that, or 10 seconds. So that's the first answer for part A. Then I also want to know what is the horizontal range. Well, now that I have the time, I say x equals vx times t. Vx was 87 meters per second. That's the x component of the velocity, times 10 seconds. That's 870 meters. And then finally, let's see, this was B. C, I want to know the vertical range, the maximum vertical range. That occurs right here at this time, which is 5 seconds. Remember, this was 10 seconds over here. So at 5 seconds, I say y equals v naught y t plus 1/2 ay t squared. And this is t top for both of these, so 5 seconds. And I solve for y. I say this is equal to 50 meters per second, because that was my v naught y. Yeah, 50 meters per second times 5 seconds plus 1/2 of negative 10 times 5 seconds squared. Let's see, that's 250 minus 5 times 25, 125. We'll call that 130. I guess actually it would be 125 meters. That is the y displacement. Two blocks are connected by a rope as in this figure. Block 1 has a mass of 3 kilograms. Coefficient of kinetic friction in the surface is 0.1. Block 2 has a mass of 2 kilograms, and the friction in the surface is 0.2, and the force F is 20. What is the acceleration and what is the tension? Okay, first let's just draw all the forces. First of all, it is accelerating in this direction. That means that my kinetic frictional force, I'll call it Fk1, is in that direction. I also have Ft in this direction. I have Fn, the normal force, 1 in that direction, and Fw1 in this direction. Similarly, over here, I have Fn2. I have F, which is already drawn here. I have Ft, and I have Fk2. And I have the weight, Fw. Now I can draw my coordinate systems for both of these. The free body diagram, you may or may not have chosen to do this. It's largely the same as what we have up here. But I have Fn1, Fw1, Fk1, and Ft. And I have Ft, recognizing that these two Ft's are exactly the same, the one here and here, Fk2, and then F over here. Now I can write my Newton's laws. I can say the sum of the forces in the y, that's Fn1 minus Fw1, that's equal to MAy, but Ay is equal to 0, so that's equal to 0. And then Ft minus Fk1 is equal to the mass times the acceleration in the x direction. So this is the sum of the forces in the x, and this is the sum of the forces in the y, the vector sum. Can do the same over here. Sum of the forces in the y equals Fn2 minus Fw2. That's equal to 0 because the acceleration in the y direction is 0. And the sum of the forces in the x is F minus Ft minus Fk2. That's equal to MAx. And AX is going to be the same for both blocks. They accelerate at the same rate. Now, notice that I can solve here for Fn1 and Fn2. I'm going to do that over here. Fn1 is equal to Fw1, which is equal to 3 kilograms times 10 meters per second squared are 30 newtons. In a similar way, Fn2 is equal to Fw2, which is equal to 20 newtons. That's 2 kilograms times 10 meters per second squared. Now I can solve then, since I know the coefficients for Fk1, which is going to be mu k1 Fn1. That mu k was 0.1 times 30, which is 3 newtons. So now I know my kinetic frictional force, and I can also find Fk2, which is mu k2 Fn2 0.2 times 20, which equals 4 newtons. So those are my frictional forces. So now if I look at my unknowns, what do I know, or rather what do I not know? I don't know my tension, I don't know my acceleration. I don't know my tension, I don't know my acceleration. Everything else I know. Let's go ahead and put in some values here, and then we can solve this. I have Ft minus Fk1, which is 3, equals to the mass m1, being careful that I get m1 and m2 here. So this is 3 kilograms times A. I'm going to drop the x subscript. And then over here I get 20 minus Ft. 20 was that force F it was given. Minus 4 equals 2 times A. Notice I used 2 kilograms for m2. Here I have two equations, two unknowns. I can solve this. Let's say Ft equals 3 plus 3a, and then we'll take this and we'll plug it in over here. So I get 20 minus 3 minus 3a, distributing that negative, minus 4 equals 2a. And I solve this. I get 20 minus 7, that's 13, equals 5. Wait, yeah, 13 equals 5a. So a then is equal to 13 over 5. 2.6 meters per second squared. Okay, so that's the acceleration. Now I can come back, take this, and I have an expression for Ft. I just plug that in there. Ft is equal to 3 plus 3 times 2.6. What's that? 11 newtons, or 10.8 newtons, 11 newtons. So those are our answers. Ft is 11 newtons, A is 2.6 meters per second squared. All right, you kick a soccer ball with an initial velocity of 12 meters per second at 30 degrees above level ground. It travels to a maximum height and then hits another player 1 meters above the ground. So here's my other player. I have this soccer ball. It follows a path that looks something like that before it hits the other player. And I know that the angle here is 30 degrees, and this is 12 meters per second. I want to know how long is the ball in the air and how far away is the other player. So I need to know the time and the distance at this point. How far to the other player, and then how much time does it take to get over there? Well, I know that that point, that y is equal to 1 meter. I know that v naught y equals to 12 sine of 30. I know that Vx, which is V naught x, is equal to 12 cosine of 30. That is 10.4. This is 6 meters per second. What else do I know? I know that Ax equals 0, Ay equals negative 10. So I can solve for y. I say y equals V naught y t plus 1/2 ay t squared. And here I know everything but t. So I'm going to put in my values here. I have 1 equals V naught y, which is 6, t minus 5 t squared, putting in my acceleration. Notice this is a quadratic equation. I have to solve this with the quadratic formula. So I'm going to rewrite it as 5t squared minus 6t plus 1 equals to 0. This is my A, this is my B, this is my C. T is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's going to be 6 plus or minus the square root of 36 minus 4 times 5 times 1 all over 2 times a, which is 2 times 5. This works out to be 6 plus or minus 4 divided by 10. So that is 10 divided by 10, or 1, or 2 divided by 10, which is 0.2. Now we need to figure out which of these times do we use. Well, there are 2 points where it is at 1 meter. There is the point right here and the point right here. And notice that it says it travels to a maximum height and then hits another player 1 meter above the ground. Now the player could be right here if it weren't for it traveling to that maximum height. So this is our time. It's at a time equal to 1 second. So that's part of the problem, finding this time of 1 second. And then also, what is the x displacement? That's going to be vx times t. See, our vx was 10.4 meters per second times 1 second, or 10.4 meters. All right, 1 second and 10.4 meters. Now let's look at this last one. Elevators accelerating as shown at 3 meters per second squared. What is the normal force on the block? So I have Fn, I have Fw. I say the sum of the forces in the y. The weight is 10 kilograms times 10 meters per second squared. The acceleration is -3. It's negative because it's going downward. So Fn equals 100 minus 30, which is equal to 70 newtons. This is akin to measuring your weight. Then when you measure your weight, you're really measuring the normal force on the scale. And if you go on an elevator and it accelerates downwards, then you feel like you're lighter. It's your normal force is less. So that is the right answer. There's our multiple choice answers.